Okay, we're on page 18. What I like to do is I like to cover parts of ellipsis day 2 and day 3 today, so that I can get to hyperbolas on Monday. And the reason why I want to do that is the quiz is still next Friday, but I think there's some students who want to take it Thursday or earlier because I just want to give them that option. So I want to try to, at least hit all the new topics by Monday if possible, and we'll go back and kind of review through the problems that we skipped over. Okay. Just to kind of get the option for students who maybe out of town later in the week and want to take the quiz earlier. Okay, so but today we're just going to try to get through ellipses. Okay, so as review, we know that ellipsis kind of has that circle formula to it, except for the fact that we have these denominator values that kind of tell us how wide to make the vertical and the horizontal from the center. So we look first to see where the center is. The center is going to be basically how you would find the center of a circle. Pull from your H and K. So in this case, the center is -6,4. I wish I had provided blanks for us to fill in, but we're just going to kind of create them for this problem. Okay, so center -6,4. Okay, now looking at this equation here, can you tell what's the A value and what's the B value? Right, right. A squared is the 25 because we know that A value is always greater than the B value. So A is 5 and B is 3, right? Okay. And also look at the fact that the A squared is under the Y, so we know that this is going to be what, a horizontal or a vertical? Yeah, this is going to be a vertical major axis. Okay, so we know our ellipse is going to have this shape to it. So just review from yesterday. We're just going to plot those points, and then also the focus as well. Well, it didn't say focus, but let's just go ahead and also find the C value and find the focus. Okay, so just review from yesterday.
So just to clarify, A is always going to be the bigger number.
A is always the bigger number,
and
right?
Always going to be called upward.
Not necessarily. It depends on whether the A value is under the Y or under the X. If the larger number is under the Y, then it's going to be vertical. It's going to be longer vertically. If your larger value is under the X, then it's going to be longer horizontally.
Thank you.
Okay, number 2, what's different about number 2? Okay, the a squared is 81, it's under the x, so we know our ellipse is going to open, it's going to be horizontal major axis. Root 17 is close to root 16. You know root 16 is 4, so root 17 is a little bit more than 4, probably like 4.1. And to keep the value of the focus as exact as possible, we're going to hold on to that root 17. All we're going to do is we're going to take that and add it to the center. Okay. But because you're moving left and right to get to the focus, you're going to do plus or minus root 17 attached to that x value 1. Okay, so just review from yesterday. Any questions? Okay, what's different about the ones below is we just have to complete the square because we're starting with general form. Okay, so it's a little bit more involved with than completing the square for circles and parabolas, because we have to hold on to that leading coefficient that may be different. So I'll go through the steps one by one. Okay, so let's look at number 3. I'm going to work this on a separate sheet just so I can have room to show everything. Okay, so here's number 3. Okay, write the standard form and graph the equation, list the coordinates. So everything, all the directions are the same. It's just that now we have an equation that's not in standard form. We have to get it into standard form. So we will do the same things that we would initially if we saw general form for circles. We would try to group the x together, group the y's together, and then push the constant over by itself on the other side. Okay. So 3x squared. Okay, so what's adding to the complexity here is the fact that we got to deal with this 3, and that 3 is not going to go away like how we were able to make it go away with circles. We can't divide everything by 3. So we're going to hold on to that 3. Now we're going to take a GCF out for the x. Okay. So take out the 3, and then we're going to complete the square with what's inside, okay, the parentheses. Okay. Does that make sense? Okay. So we still want to complete the square with an x squared, leading coefficient 1, but we're pushing that 3 outside, and we're taking care of it with the 6. Now, there's no need to do that with the y's, because the y's already has a coefficient of 1. So we can just write that portion without a parentheses. Okay. Now, complete the square. Initially, it's going to feel the same. What goes into space is b over 2 squared. Okay, what's the b value for the x? 6. Okay, so 6 over 2 is 3. 3 squared is 9. Okay, now here's the thing. You put a 9 here, okay, but it's actually not going to be a 9 right here. Do you know why? Yeah, we got to multiply by that coefficient. That 9 is not really a 9. That 9 is really a 27 because it's inside the parentheses with the 3 outside. So that is the thing that is making things a little different for us here. 27 goes there. Okay, does everybody see that? Now this one will be the same numbers because there's no factor in front of the y, but there's a factor in front of the x, so we have to make that adjustment. Okay. Over here, my b value is 2. 2 over 2 is 1. 1 squared is 1. Okay, 1 and 1. Okay. So we keep going. We're going to factor what's inside the parentheses here. Multiplies to be 9, adds it to be 6. That's going to be x plus 3, x plus 3. Multiplies to be 1, adds it to be negative 2. That's going to be y minus 1, y minus 1. Add the like terms on the right side. Okay, will give us 24. Okay, we do further cleanup here. Okay, now what's different here is, okay, we're not, there's not a circle, there's no radius, but if you look at standard form for an ellipse, what is always on the right side? 1. Okay, so we're going to force a 1 on the right side. So the way we can force a 1 is do what? Good. Divide everything by 24. Okay. Remember our goal here. Our goal is to get it into standard form so that we can see all the necessary pieces for us to graph our ellipse. Okay, let's reduce each fraction here. Okay, 3 and 24 reduces to be what in the denominator? Just 8, right? Mm-hmm. (24) stays equals 1. All right, this is going to feel a little messy because we're not going to get whole numbers as we graph, but we'll just make our estimation using what we know about square roots. Okay, so first thing is, well, we're now at standard form. Transfer this over here. All right. What's the A value? A is square root of 24. We know that square root of 24 is close to root 25, so that's a little bit less than 5. Okay, our B value is square root of 8. You know square root of 9 is 3, so square root of 8 is going to be a little bit less than 3, like 2.9. So now how is this, oops, I should put this over here. How is this going to be here? Is it going to be a vertical major axis or horizontal? Vertical, right? You see that the larger value is under the y is going to be a vertical major axis. Okay. All right, let's see if we can fill this out here. Center is -3. We're going to count up and down to get to our A value, to get to our vertex. And it's going to be a little bit less than 5, so what, 4.9. And then we know that our B value, 8 is under the X, we're going to go left and right. We'll be a little bit under 3, so like 2.9. Now to write our vertices, we're just going to take the center, and because we're moving up and down, we're going to take that A value and we're going to attach it to the Y value because we've moved basically 4.9 up and down, but we want to leave it as exact value. So we'll say plus or minus root 24 attached to the 1 because we're impacting the Y value. However, the B value, we're moving left and right. So we're going to make that root 8 impact the -3. So similar to how we were approaching it from the focus standpoint. All right, we still have to find the focus. C squared equals A squared minus B squared. So this feels a little bit strange, right? It's the focus that's going to be nice whole numbers, and it's going to be the vertices and co-vertices that's not going to be a nice whole number here. Okay, eccentricity, same as before, C over A. Okay, let's go. Let's do the practice 8.09, number 1. And I think for now, if you guys can use your calculator, I know some of these numbers are a little bit larger. Okay, so let's look at number 1 below. All right, let's group the x's together. Well, yeah, it looks like everything's already grouped together here. All right, we always want to take the GCF of the x's and then separately for the y's. So GCF for the x. So take out a GCF of 4 just for the x's. If I do 56 divided by 4, I get 14. And go ahead and add a space because we know we want to complete the square for the x's. Same thing, we're going to take a GCF out for the y's. Sorry, not true GCF. We still want to hold on to the y squared and y inside. So we just want to take the factor for the coefficient. Don't take out the x's and the y's. We want to leave those in there for factoring purposes. All right, complete the square. Seven squared is 49, but we got to be careful. 49 is here, but it's inside a set of parentheses. We're not going to put 49 here, right? We're going to put what? Yeah, 49 times 4, 496. Does that make sense? Okay, so that's what's a little different with completing the square with ellipses, and we're going to see that with hyperbolas as well, that a lot of times in general form, we got to deal with a set of parentheses, and after you complete the square, these numbers are not going to look the same because there's something outside of it. Okay, b over 2 squared here. $36 goes in the first space, but then we got to do 36 times 9. Okay, we go ahead and factor, multiplies to be 49, adds it to be 14. X plus 7, x plus 7. I'll just go ahead and merge those together and say x plus 7 squared. Multiplies to be 36, adds it to be 12, 6 and 6. Okay. Any questions so far? Okay, we're almost there. The right side, though, for ellipses, we want to force a 1. So the force of 1, we got to do what? Divide everything by 36. Okay, reduce, reduce. Okay, so now we're back to nice, clean, perfect squares for our a and b value. Okay, so now it's just going to feel like yesterday, right? Just getting your a, getting your b, getting your center, graphing, finding your vertex, co-vertices, your c value, your focus. Okay, so to get to your vertices, larger value is under the x. You're going to go left and right 3 units to get to your vertex. And you go up and down 2 units to get to your y, to get to your co-vertices. Okay, remember, the larger value will take you to your vertex. Sorry, left off the foci, if you can put that in there. Root 5 is a little bit more than 2, 2.1 maybe. And you're moving left and right to get to the focus, so you're just going to take that C value and you're going to make it impact the X value of your center. Okay, any questions here? Okay, let's do one more, complete the square for ellipses. And I'd like to shift over to day 3, where we're given a bunch of characteristics and we got to write the equation. So if you can turn to page 19, go ahead and try number 2. Oh, we've got to find eccentricity. Sorry, that line got cut off. So your eccentricity here. C over A. Root 5 over 3, right? That line got pushed to the next page. Okay, go ahead and try number 2 on page 19. Okay, look at how number 2 is set up. This is definitely not in standard form, but do we have to complete the square for both the variables? Yes. No. Just what? Just the y's, yeah. Now, this 49x squared, we know we got to deal with it down the line, but we don't have to complete the square for the x's because we don't have x squared and x. It's just x squared. So only have to deal with the y's. So we'll leave the 49x squared alone. We'll deal with it later, but it's only the y that we have to work on to complete the square and factor. So I'm going to go ahead and take care of that factoring step. Take out 16. (160) divided by 16 is 10. Go ahead and set myself up for complete the square. Move that 384 over to the right side. All I need is one space on either side of the equal sign. Okay, does everybody see that? Why we don't need complete the square for the x's? Okay. Okay, formula, b over 2 squared. My b value is 10. Five squared is 25. Again, we gotta be careful with ellipses. This 25 is not going to show up here. It's going to be what? 25 times 16. Yeah. All right, let's do some cleanup here. Multiplies to be 25, adds up to be 10. That's 5 and 5. Okay, what's next? Divide everything by 784. Okay. Okay. The nice thing is that 784 is made up of 49 times 16, so everything will work out cleanly here. 49 goes into 784 16 times. (16) goes into 784 49 times. Okay, so now it just feels like yesterday, right? You can find the center, find your A value, find your B value, graph your ellipse, find your C value, get to your focus. Root 33 is close to root 36. Root 36 is 6, a little bit less than 6. You're moving your focus up and down from the center, so you'll just take your center and you're just going to add the plus or minus c value to your -5, to your y value. Okay, I'd like to do a little bit of practice into day 3, or a little bit of introduction into day 3. So once you're done with this, we're going to try to just get through number 1 and 2 on page 20. So again, just want to get a little bit ahead. Not going to change the day of the test, but just want to, or day of the quiz, but just want to give the option for any students who want to take it earlier and able to get through the all the new material sooner. Okay, does anybody still need page 19?
Can you give us a number? 1 or 2?
Sure. Hold on. Which?
Oh, I see. I thought that was over here.
Oh.
Thank you.
Okay, thanks. Okay, page 20. Okay, it says the center. Okay, so here we want to write the equation of the ellipse. So up to this point, we're given the equation, and we have to find characteristics and then graph it. But here we're given characteristics, and from the characteristics, we want to be able to pull and find the A, the B, and the center to create that equation. And also, we're going to graph to kind of help us find those missing characteristics to fill into the equation. Okay, so let's read the problem here. It says the center is at -3, -1, so that's our HK. The length of the horizontal semi-major axis. So you see the word major, you see horizontal, you know it's going to be, it's going to look more like this. And if that's the case, we know that our A value is going to be under the X. And just from that, we can just go ahead and write out our target equation that we're going to be focusing on. Now, we haven't seen this word here, semi-major axis. So semi-major axis means half the length is 7 units, or half the major axis is 7 units. So that's basically telling you what the A value is. So it doesn't make any adjustment. It's not telling us the full distance. It's telling us half the distance. And if it's half the distance, we know that's the A value, right? Because A value is from the center to a point on the ellipse. So that's good. They're giving us that A value. So A is 7. And the length of the semi-minor axis is 5 units. So that's our what value there? B, yeah. So that makes it easier because everything is pretty much given to us. We just have to put it into the equation and also to graph it as well. All right, so to write the equation, we can just put it into this form here. HK inserts into the equation the A and B. Make sure we square them. So here's our equation. Okay, so now it just feels like the previous problem in the past, just gathering all the information. Horizontal major axis, we see the 49 is under the X. We're going to go A value to get to our vertex. We're going to go left and right 7 units. Root 24 is a little bit less than root 25, so it's like 4 point something. Remember, your C value is going to go always the same direction as your A. So whichever direction you move to get to your that you move your A, you're going to move your focus is always going to be the same orientation as your A. Right? So because we move left and right for the A, we're going to move left and right to get to the C or to get to the focus. We're going to attach that root 24 to the X value of the center. Root 24, not 26. Okay, let's finish up with number 2. Oh, sorry, let me change this problem here. This is a little more difficult to work with. You guys can change this to 0, 2, and negative 4, 2. Again, change number 2. We'll let the foci be 0, 2, and negative 4, 2. Okay, focus is across from each other, okay, horizontally. So which orientation is this going to be? Yeah, it's also horizontal major axis, right? You look at how focus and vertices or co-vertices, you look at the orientation, and instantly you already know which form it has to be, right? The only way focus will be directly across from each other is if it's on that horizontal axis. Okay. Now, if I know the focus, what information can I find? Center, right? Because center is directly between it. The A value is given to you, so that's nice. A is 7. What's the C value?
Oh,
2, right? Distance from the center to the focus. So to find the B value, we got to go through our formula. C squared equals A squared minus B squared. But now we have to solve for a different variable, right? We're used to solving for C, but I mean, if we have 2 variables, we can always find any missing third variable, regardless of which one it is. Oops, sorry. 4, not 49. Okay, root 45 is close to root 49. Root 49 is 7, so a little bit less than 7. I'm moving my B value up and down to get to my co-vertex, so I'll just attach that B value to the Y of my center. Okay, let me just check your pages 18, 19, 20 for the ones that we did do.